Welcome back to Homework Help with Jen. This is Chapter 5, Problem 63, and this is probably the first one in this chapter that I'll do. Typically, the students find that the gas laws that come at the beginning of the chapter aren't very difficult, so we'll begin here. Also, one of the reasons I'm beginning with this one is that I have a note to myself that the back of the book has an incorrect answer for Problem 63. Okay, so we start with a reaction. For solid aluminum plus 3 oxygen gas yields 2 aluminum oxide solid. And then it says that it takes 2 liters of pure oxygen gas at STP to react completely with a certain sample of aluminum. What is the mass of aluminum reacted? Alright, so we'll come over here, and here what I've done is I've taken this information and I have put it kind of in this form, like I do in class, and I've put the information where it needs to go in kind of a table form, and I see that I'm looking for my mass of my aluminum. Now there's two ways to do this. See? 2 ways. Okay. And the reason for that is because we're at STP, we notice that temperature is equal to 0 degrees Celsius or 273 kelvins, and pressure is equal to 1 atmosphere. When this happens, we have what's called molar volume of a gas. The molar volume of a gas at STP is always, you should remember this from class, 22.4 liters per mole. Okay, so that means for every mole of gas we have 22.4 liters. Okay, so what we can do is we can do a stoichiometry based on this information. And we can say, okay, well, we have 2 liters of oxygen gas, times 22.4 liters per mole. Okay, so we have liters on the bottom and liters on the top, and they cancel. Okay, this is O2 times. Okay, now what we're going to do is we're going to use the mole ratio from above, and that tells us that we have 3 moles of O2 for every 4 moles of aluminum. And then last but not least, in 1 mole of aluminum, okay, and of course this we take from the periodic table. So here's aluminum number 13, 26.982 grams aluminum. Oh, I didn't give myself enough room. Okay, so I'm going to come down here with the answer to that, because on the other side of the paper I'm going to be talking about the other way to do it if we were not at STP. Okay, so I say 2 divided by 22.4, okay, and then multiply that by 4 and divide it by 3. You might be doing this differently on your calculator, times 26.982, and this gives me 3.2 grams of aluminum. Alright, so if I've done that correctly, then it should make sense in a minute. We're going to now do it in a second way. Perhaps there isn't an error in the back of the book. Okay, so the other way to do this is to do what we call kind of a standard method for gas stoichiometry, and that's that we use the ideal gas law, PV equals nRT, and stoichiometry, and either we do, and it depends on which one we do first. Okay, so since we're beginning with a volume, we would do the ideal gas law first, and we would say, okay, well, number 1, this is our step 1, we use the ideal gas law, PV equals nRT. Okay, and what we need to do is we need to find the number of moles of oxygen that we're dealing with. Okay, and that is because we need the number of moles of oxygen in order to find the number of moles and then the mass of the aluminum. Okay, so we solve N of our O2 is equal to PV divided by RT. Okay, so this means that our pressure is 1 atmosphere, And our volume, well, they tell us we have 2 liters for our volume. Whoops, divided by, don't have enough hands here, divided by our 0.08206 times our temperature, which is 273 kelvins. And this tells us, now if I do the math, 2 divided by 0.08206 divided by 273. So if I let myself have 3 significant figures, then I would say that I have 0.0893 moles of oxygen. Okay, now the second step is to do a short miniature stoichiometry using that information. So I say, okay, I have 0.0893 moles O2. Okay, now it's going to look the same as what we have over there, which gives me 4 moles of aluminum for 3 moles of O2 times 26.982 grams of aluminum per mole of aluminum. Okay. So if I do this, I take my 0.0893 and I multiply it by 4 and divide it by 3, okay, and then multiply it by 26.982, and brilliantly I get 3.21. I must have cut this off a little bit early, which is probably a no-no, but 3.2 grams of aluminum. And you can see that they match. So that means, yikes, that we did it correctly. Okay, so what I had written down in my book doesn't really match what I had said about that. So bear with me for a minute. This is going to take a second. We're going to switch to the back. You can check out if you've got the back of your book's answer already there. But while I'm still talking, we're going to look this up real quick and see exactly what they say, since I had a note that it was wrong. I apologize if we're going through this for nothing. And we find here, we find number, no, and they do. So it is not wrong. It is 3.21 grams of aluminum, which is fabulous. So I'm not sure why I had that note to myself, but hey, that's a nice big problem that you guys just got to see, and hopefully that sheds a lot of light on stuff.